All right, anyway. Okay, so for this example, right? Drawing again one card from a standard deck of cards, okay? We want to know the probability that the card is an ace or a king. Excuse me. Well, we're going to let A be the event, okay, that the card is an ace. And B be the event the card is a king. We know there are 4 aces in the deck, right? The probability of A is this, 4 out of 52. The probability of B, okay, is also 4 out of 52 because there are 4 kings in the deck. And these events, they're mutually exclusive, right? You don't have any cards in there that are both ace and king. You're only one or the other. You can't be both. Okay? So because of that, the probability that of A and B is 0, which you can just leave as 0. I wrote it as 0 over 52, but if you just write 0, that's fine. So altogether, the probability of A or B, right, that's equal to this. The probability of A plus the probability of B minus the probability of A and B. So in this case, you get 4 over 52 plus 4 over 52 minus 0, which is 8 over 52. So that's what we get. Not sure what that number is as a decimal, but that's fine. I hope that makes sense to everyone. Are there any questions? Again, the notes are in your inbox. I did email them, so. Okay. Well, when you're dealing with these probability questions, you can see that, if you were able to have everything in the sample space, and, things would be pretty simple. Unfortunately, we don't always have that. For certain examples, we were able to get the sample space, that is all the outcomes easily, but you're not able to always get every single outcome. That is, you're not able to list them all. I mean, theoretically, you could do that, but that's not very efficient. I mean, for instance, if you saw the experiments where we were drawing a card from a deck of 52 cards, and then drawing another one, in that case, there's going to be more than 2,000 outcomes. You have 52 possibilities for the first card, then you have 51 possibilities for the second. To account for all that, you'll end up with more than 2,000 outcomes. I mean, I don't know about you, but I definitely do not want to list all those outcomes. What's nice is we really don't have to. As we'll see. Or here's one maybe that's not as bad. If you're rolling a 6-sided die, twice, and you want to know how many possible outcomes there are, you roll it, record the number, then you roll again, record the number. It turns out there are 36 possible outcomes there. That's not terrible, but still. Now, first, I just want to go through a good way to list all the outcomes. It's actually what they call a tree diagram. I mean, you could use a table. I guess you really, theoretically, you could just list all the outcomes, but the tree diagram is a little more efficient. And I'm actually doing the example that the book does. Basically, the example is this. We're at a restaurant, okay? And the restaurant has 3 choices for the appetizer. Okay, what you eat before the meal. So we have soup, a salad, or just breadsticks. Okay? And for the meal, there's 5 choices. You have hamburger, a sandwich you can have quiche, fajita, or pizza. Okay? I don't know what restaurant this is, but that doesn't matter. Okay? Let's suppose we can only have one item from each, for whatever reason. We want to know how many different options do we have, or how many possibilities are there. Well, what we could do is we can list them all using a tree. As I start doing here, basically the idea is this. You have a little point here, right? That's something. What you next do is you would list a branch for each of the 5 outcomes. So I'm listing the meal first. You really don't have to do that, but for me, it's a little bit easier. I mean, I think so at least. But we have a branch for each of the 5 outcomes, as you can see. Then, okay, from each of these 5 outcomes, right, we have hamburger, sandwich, fajita, quiche, and pizza. And excuse me, pizza, I think I said that wrong. For hamburger, right, we have those 3 branches we have for each appetizer possibility. Bread is just breadsticks, soup, and we have salad. I mean, you would have the same thing for sandwich, bread, sticks, soup, and salad. So again, we had that point up top. That is, the branches start out from there. 1 branch for each meal. And from each meal, you have the 3 possibilities, namely the 3 possible appetizers. Okay? And usually when in a tree, I think the branches go up. So I know it's kind of silly we call this a tree, but that's just what people do. But anyway, if you were to list everything, you would have this. Now, how do you get the outcomes from this? Well, essentially what you do is you start at the very top here, and you take a path all the way down. Each path you take gives you an outcome. For instance, if you went down to hamburger, you go down to bread. So that would give you hamburger, then breadsticks. That's one outcome. Another one would be hamburger, then salad. That's a second outcome. Or hamburger and soup, whatever. And you keep on going. So not only can you list the outcomes, you can also count how many there are. You just count how many branches there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I mean, listing the outcomes is not really the best thing to do. I mean, what's nice about the tree example here is that it's efficient. But really what's more important here is what's called the counting principle, which is determining how many outcomes there are. Now, if we have to choose one, so here's the counting principle. Some books call it the multiplication rule. They're saying it's also called the multiplication rule for probabilities. So you'll see why it's called the multiplication rule. Basically, if you're asked to choose one item from 2 separate categories, and from the first category, there are m possible items, okay? And from the second category, there are n possible items. Then in total, there are m times n possible choices. Or there are m times n possible, possible choices, that's right. So again, if you have 2, so basically what they're saying is, if there are m possible choices from the first category, and n possible choices from the second, there are m possible choices from the first category, n possible choices from the second, and in total there are m times n possibilities. So essentially you just multiply, hence the name multiplication rule. That's all. I mean, here I just wrote out how I actually formed the tree. I did say it in words. Basically, as I said before, you start from a point, you going to draw a branch for each of the m items in the first category. Then you're going to, from each of those items, each of those m items, you draw n branches. N branches for the second category. And in the end, you'll have m times n possible outcomes. You know, here, m times n possible branches. That's good. You could actually keep on going with this. If there was a third category, let's say, with w items, and we had to choose something from there as well, then in total, there would be m times n times w choices. M times n times w, choices. Okay? So basically, you just multiply, is what we're trying to say. That's actually how, from the example with the deck of cards, how I got the total number of outcomes, you know, the probabilities, that is. What I did was I multiplied, right? With the deck of cards, there are 52 cards for the, let me see, actually, see if I can get back there. Not there, come on. There. Here, there are 52 choices for the first card, right? You're choosing 2 cards. And for the second card, there's 51 choices, right? So we multiply. That's how many choices there are. So you could think of the categories as 52 cards from the first category. The first category, I guess, would be all the cards, the collection of all the cards. In the second category, there's 1 card left, so there's 51. And in total, then, the total number of possibilities is 52 times 51. That's how many outcomes there are. Even with, let me see if I can get to it. Come on. Here, even with this example with the meal and the appetizer, there's 15 possibilities, right? But there were 5 meals, you know, so the meal would be the first category. There are 3 choices for the appetizer. So you can think of the appetizer as the second category. In total, there are 5 times 3 possibilities, which is 15, as you can see. So you just multiply. I mean, another example I put here was, if you're rolling a die twice and you record the number each time, right? How many possible outcomes are there? Well, each time you roll the die, there are 6 possible numbers, right? So you have 6 on the first die, possible choices. Rolling it a second time, you have 6 from that possibility as well. Hold on. You have 6 possible numbers from the first roll. You have 6 possible numbers from the second roll. So in total, since you're rolling it twice, you have 6 times 6, which is 36 possible outcomes. Again, you could think of the categories as the possible numbers from rolling the die, if you want. You know, here we had categories, right? You could think of each category as all the numbers you can get from rolling the die. So if we were rolling the die a third time, right? You would have to multiply by 6 again. The third category would have 6 possible numbers, and you would have 6 times 6 times 6, which is 216, I think. The tree diagram would look like this. This is for 2 rolls, though. The first roll, and then the second roll. I really hope it's making sense what I'm saying. I think it is. Okay. I mean, that's it for, not for the chapter, but for today, that is. I mean,